Welcome back, everybody. Another fun video here at Blue Glow Electronics. Today on the bench we have a Sherwood model S-5500 III. It says it's an 80-watt stereo amplifier. These are pretty rare birds. I've only worked on probably two others in my entire time, so I've not seen a lot of these come across the bench, but they're fairly simple units and fairly easy to work on. This one's really nice and clean, got a nice faceplate to it. This one was mounted inside of a stereo console that someone had made with a turntable and such, so it doesn't have the cover. If you take a look on the inside, you can tell that it's gotten some rust on the transformers over time, and certainly dirty here. The back side here's got some rust on the tube covers, as well as I noticed one side of the tube cover was broke loose over here. I'll have to resolder that. I've done some testing of the tubes in this thing. The output tubes are fairly weak in this thing, and I've let the customer know that, as well as some of these capacitors didn't test out so good, the large electrolytics. But you know, what he really wanted to do was basically get the unit functional. Didn't want to do a full restoration on it, which would include kind of you know, cleaning up and painting, pulling the transformer end bells and painting those, as well as I think he's okay with just some weaker output tubes as long as it still plays. So a little bit of a you know, a budget restoration on this thing, but I think we'll have a lot of fun doing it. Let's dive in and see what all it needs. Okay, a couple things here. It looks really nice and clean on the underneath, so that's good news. A couple things I found, and I will go through and test these things again here, but you certainly got some electrolytic capacitors here kind of that need replacing. Coupling caps here on the output. These got the older brown dog bones, and sometimes these things are okay. You know, they're kind of viewed as really good long-lasting capacitors, but I've also seen them leaky as well, so we'll test those out. And we got some other coupling capacitors up here on the front end, as well as electrolytics here we're wanting to check out really good on this thing. Okay, just put a fuse in this thing. It did not have a fuse in it when I got it. Put a 3-amp slow blow in there, and are slowly bringing this thing up on the variac. It actually started, we're at 88 volts right now. It started playing music, but thought you'd get a kick out of this. I don't think these volume controls have ever been touched in their entire lifetime. Watch this here. See all the noise on the pots. Same with the balance. As you're turning it, it's dropping, signals dropping completely in and out. So definitely need to clean these things. Okay, several things I've figured out about this amplifier thus far. One, some of the electrolytics in it have some high ESR. So while this amp is running right now, if we don't do something to address the highest ESR, these things are just going to run hot over time and eventually fail. The second thing I'm noticing here is that the bias on the outputs is significantly different. If you'll notice here, I'm getting about 15 volts on these two tubes over here as a pair. Negative 15 volts on the grids, and over here on this side, negative 0.3, 0.4, and it's bouncing around a good bit. So these two tubes here, they are got a little bit of glow to them right now, so I'm going to power this thing back down until I can figure out what's got the bias all out of whack on this side. Let's take a look at the schematic. Okay, a couple things to note. These are the 7868s here on the output, and if you'll notice, there's another pair here, so both sides of the amplifier. Interestingly, the cathodes of these things are all tied here. All four of them are tied to ground here, which actually then goes over here to the to the ground speaker lug. So cathodes are all at 0 potential, which likely means this thing is a fixed bias setup, which is the case. And so the bias is being fed here into the grids. If you'll notice the little, you come off of the grid here with a 1K grid resistor here, then it feeds over into R44 and R45, which is just a voltage splitter here, and then it goes over and it goes to B1. And if you'll notice this one over here, the pair of them ultimately feed out of the grids here through the 1K, through a similar divider network there, and goes to B2. So one thing to note about that is these two are tied together because of where they're feeding over here to B2, which is a voltage supply for the negative voltage for the grids. There's no way to independently bias these tubes. So these two tubes get biased together because they're feeding to this same B2 point, and these two tubes get biased together because they're feeding to the same B1 negative voltage for the grids. And the only downside to that scenario is that you need to put matched tubes in the outputs of these things, because you're going to be applying the same negative voltage to the grid. If one tube pulled a different plate or current than the other, then these things with the same bias would be out of whack. So let's scroll over and look at B1 and B2. Okay, let's take a look at the power supply on this thing. We've got 120 volts here on the mains on the input feeding to the primary of the power transformer. Then this thing has multiple sets of secondary windings here. This set here is used to feed the kind of high voltage. Looks like this here is used to feed some filaments on the 7868s, as well as some of the lamps on this unit. And then this top setup here is what creates your negative bias for the output tubes. If you'll notice here, you have two diodes here, so creating a solid state rectification. Then you're feeding into a CRC filter here, two 300 microfarad capacitors and a 22 ohm. So coming out the other side of that, my guess is here you've got about 24 volts sitting there. They don't actually show you here that number, but the fact that you've got two 12AX7s connected in series, so pin 5 and pin 4, pin 5 and pin 4, and if you look at a kind of a 12AX7 pin out, you'll notice here pins 4 go all the way over, and pin 5, that's, you need to put 12 volts across that to feed it. You can on a 12AX7 feed halfway, like from pins 4 to 9 or pins 9 to 5 here with 6 volts, but that's not the case of what's going on here. So the fact you've got two 12-volt filaments in series here leads me to believe you've got about 24 volts sitting across there. Then you move into a little bit of another RC filter here. Then this is where you get into kind of a voltage divider network here of that 24 volts. You've got a 22K resistor along with a 5K potentiometer, and this points B1 and B2 here are tied to the wiper of that 5K potentiometer. So if you think about this as just standard voltage divider, as you move this wiper up and down on this resistor, you're basically changing the voltage on this thing. And what it's telling you here is this thing needs to be fed between -17 and -22 volts coming out of that point, feeding over into the grids of these tubes. The same here with this one. Okay, just deducing what may be wrong with the bias on this amplifier. It's one of two things. Either one, these potentiometers here are just way out of whack. Someone's been playing with one of them, and one of them's not too far out of whack. Remember, it was about -15 volts, but we need to get it up to more like -17 to 22. And matter of fact, we're going to go look at the 7868 data sheet here. And one thing we'll notice, if we scroll down till we get to push-pull audio frequency power amplifier, which is what this would be, and then we roll down to a fixed bias operation, and we start looking here at the grid voltages for number one grid. It says it could be anywhere from minus 12.5 to minus 21. And what kind of determines that is, one, we've got to figure out the plate voltage and how much we're applying to it. And then the other thing is it could be varying based upon the the output impedance of the output transformers. But my guess is these things are around the 6600 ohms here that it's asking for. So we're going to measure the voltage here, and based on that figure out the exact voltage we want to put on those things. They give us a little bit of leeway in this schematic when they told us from minus 17 to minus 22. I want to figure out exactly where in there we want to be. But one of two things is causing this, as I mentioned. Either one of these bias pots is way out of whack, and we can adjust that and see. Or the more likely suspect is that these 0.068 coupling capacitors right here on one side of this are leaky. So if these things are leaky, well, you've got voltage sitting right here, that DC voltage that would be leaking across, and it's a positive DC voltage. So if you added that positive DC voltage to this negative DC voltage here in B1, it would take away from whatever negative voltage is there and start bringing it more positive, which might explain why we're sitting around, only a 1 volt negative versus the 17. But we can go over here and figure that out using just nothing more than a multimeter and a screwdriver to play with the potentiometers. Okay, before I jump back over there, I went and measured real quick the plate voltage on these 7860H, which is on pin 9, and there's 441 volts on those things, so roughly 450 volts. So if you kind of look at that, it's telling me this thing should be around 16.5 volts here on the negative bias, and looks like maybe they're running it just a little bit hotter here on these things by running them at the minus 17 volts. So we're going to go with the factory recommended 17 volts. It's close enough to the data sheet at 16.5. Okay, one thing I'm going to do is I'm going to clean these potentiometers here, because they're likely as corroded as these on the front. You saw how those played out earlier on the oscilloscope. Hey, good news. After cleaning these two pots here, it turns out that I got minus 17.5 volts on these and minus 17.28. Now, one thing I will tell you is that these things are maxed out now at the very one end of their potentiometer range. And what I'm guessing now from the schematic is these things are designed to let you adjust between 17 and 22 is basically what they're designed. And the reason they're a little bit higher than what the schematic shows is when that schematic was designed, we were feeding these things with 110 volts, and most modern lines today feed more like 117 to 120 volts. So it raises all the voltages inside the amplifier a little bit. But the good news is for me is that we really don't have I don't think these coupling capacitors are leaking. If you notice, like, we've got 54 volts on that side of one, 293 volts on that side, 54 volts on that side, 290 volts on that side, and 51 volts on that side. And if we come over here to the other side, really all we're picking up now is the voltage coming from this side, which would be the minus 17 volts that we're feeding it. So it's not positive voltage on this side leaking through the capacitor, offsetting the voltage on the other side, which is often a likely scenario. But good things, these 0.68 old dog bones here seem to be in good shape, so won't have to replace those after all. And it turned out that these two tubes that were glowing slightly earlier have stopped glowing now that they have minus 17 volts on their output versus the minus 1 volt. And it was all, the culprit here was just simply these potentiometers had gotten corroded that feed the bias on one of them, and wasn't feeding the proper voltage through it, negative to the grids on these tubes. Okay, so up next I do want to go in here and replace this capacitor down here and this one here. They're both wax paper style. Definitely need replacing. Not going to replace these coupling capacitors. They seem to be testing out good, but we're going to go in and fix these electrolytics that need some sections replaced in them, and then at that point we're going to rebias this thing, because just in case these electrolytics are causing any voltage drops throughout this thing. Okay, we've replaced this little 50 microfarad at 3 volt capacitor right here with I actually had a 47 microfarad at 40 volts, so a little Phillips capacitor. I put it right here, and then up here we have replaced the 100 microfarad at 30 volts with a 100 microfarad at 100 volts. And one thing to note on this one, this is the negative bias supply, so the positive part actually goes to ground here, and the negative side of this capacitor ties over here to the wiper of the where the 17 volts is feeding from. Okay, we've been using the Peak Atlas ESR meter going through the power supply, testing all the capacitor segments. You know, check the 120 here, the 120 here, the 30, the 50, the 40, the 30, the 20. Up here you've got two 300 microfarads and 100 microfarad. And most of these have tested out good. A couple of them showed in-circuit leaky, and I had to disconnect the connections from them so I could actually test them out. But the one that's given me the most trouble is this C61 right here. It's showing about 16 ohms of ESR equivalent series resistance. So basically you could equate that out to being a capacitor here which should block DC, but in series with it you've got a 16 ohm resistor coming down through here. We're going to tackle this thing here and kind of replace the segments. I will leave the original capacitor in place for the aesthetics of the amplifier, but we kind of got to bypass this thing at this point in time. Okay, these are the two capacitors that I'm needing to replace. This one here is the one testing with the really high ESR on it, and this one here I'm going to go ahead and do it while I'm at it, because these two kind of act in unison here. And as you can see, this is not going to be a trivial undertaking. It's all underneath the fuse holder, all underneath this spare socket here. You've got this capacitor here that's kind of being used for noise, and it's going to be fun. All I got to say is this would not be for the amateur. This job will consume a good bit of an hour and a half or so, I bet. I'm going to replace them with some 150 microfarad. These are originally 120 at 275 volts. Since they're the first stage coming off of a coupling, the power supply, and it's not a tube power supply, it's solid state rectified here, I'm going to go with something just slightly larger, 150 microfarads at 450. These are some Nippon capacitors. These little suckers get expensive when you start getting 150 or 120 microfarads at 400 volts or more. But good thing is those things should last a long time once in here. So I'm going to dive in and do this. I'm probably not going to walk you through every step of it because it's going to be tedious. If you end up needing to replace these, I would recommend getting these to a professional, and or just taking your time. A considerable amount of time will be wrapped up in this. You know, just studying this thing a little bit, the toughest thing I'm going to have here is I want to leave these electrolytics in place on the top just for aesthetics purposes. And I'm going to want to mount these underneath, and just finding a location like that right there doesn't work. There's just very little room down inside of here. I might can get one right here that would mount in place. But finding room here for two of these without removing a socket or doing something else is going to be a feed in itself. You know, I can always mount one like way over here and you know, solder some wires to it and run over here and connect, which may be what we end up having to do. Okay, oddly enough, the can is negative on both of these, but this one has you know, cover on the outside of it, and that is because the can, even though it's negative, does not tie to ground here in this scenario. The kind of can itself connects over to the next capacitor here. So you just got to be careful in how you wire these things up, paying attention to how these original ones are wired. Okay, one thing it's kind of hard to see down in here, but one can's negative ties directly to the other can's positive over here. And so I'm going to do that here simply by taking the negative of one can, tying it directly to the positive of the other can, and then this little dog bone capacitor here ends up going down and soldering to the middle piece of that. And then we just got to find a place to fit all this. Okay, this is something neat I picked up. It's just a little simple $35 SMD rework station, but I really didn't need it for the rework station. What I actually got it for was, hang on a second. I do so much heat shrink tubing here, and this is so much better at being able to apply directly to the heat shrink tubing without heating up the rest of your whole unit here. Absolutely love that. So that was part of my Christmas present from my wife. I've been very happy with it thus far to have it on the bench. I probably used it 6 times since Christmas. But all I'm doing now is jumping from this dog bone over here into this middle point here where it originally was down here in between these capacitors. Okay, at this point we've got these 2 capacitors in here. I got them kind of not only soldered down because they feed over here to this ground, but also you know, zip tied down to these wires, and they're pretty solid in there, not going anywhere. And then I've had to make a couple feeds over here to other connection points that these things originally made using some PTFE or Teflon silver coated wire. But at this point, both these 120 microfarad capacitors, while still mounted in the chassis, are out of play, and we've got this all mounted up in here nice and neat. And these should you know, last another 50 years or so. You know, we could go through and replace all the electrolytics, and this thing may go for many years. But I think the customer is more interested in just getting it up and running, and these others are testing okay now. It's not to say they won't go out in a few years or you know, 5 or 10 years down the road, but that's the case with about any electrolytic capacitor. These may outlast me. Okay, we've powered this thing up now, and you see B plus here is leveling out at this point in time. About 415 volts. Let's see how this thing. It's coming, get it in the end, son. Not before I do, not before I do. Okay, sounding good actually at this point, and I'm pretty happy with how it's playing out here. I want to I do want to go back through now and check the bias on this thing again, just to make sure it's still sitting where it needs to be. And yeah, we're still getting the minus 17 volts here that we had kind of planned on. Yeah, it's looking good. I think based on that, I've already deoxed these things. I do need to work them a good little bit, though I haven't done that. All things do not be trapped by the sophistry of the world. There will never be doubt in our minds concerning the truth of this work and the great mission of this think electrically we've about got this thing wrapped up now. You know, I would say the one thing interesting, let me show you this. Okay, I know it's upside down here, but this is the model S-5500 3 80-watt stereo amplifier. Well, that 80 watts is, they were getting into the games already back then of how they rated amplifiers. What that is total input wattage into this amplifier. So if you kind of took the input 120 volts and kind of measured the current it was pulling on this amplifier, this thing would be consuming 80 watts of power total. But the reality is these things are not all that efficient, and there's nowhere near 80 watts making it to the output tubes here. It's probably more like a 65 watt or 60 watt amplifier on the output. But thought it's interesting they had started down that path already with how they calculate wattage on an amplifier. Okay, you know, I kind of mentioned I was doing a restoration on this thing to get it functional, not necessarily a full restoration and or you know, not a lot of advanced modifications to it, just basically trying to get this thing functional on a budget. But if you know, if it was mine, or maybe one that someone wanted to sink a lot more money into, one thing I would do is, in parallel with these the 22K and the 5K here that's feeding the bias one spot here for the grid bias on two of the tubes, that's in parallel with the same 22K and 5K potentiometer for the other set of two tubes, you could put another 22K and 5K pot right here, and then another one down here in parallel with that. And so you'd have B1, B2, B3, B4, and you would actually be feeding all four tubes individual bias, and you'd have individual adjustment per tube. And then you would basically break this point right here, and you would feed B1 up to this top tube. You would feed B2 then through this 150K, 47K here, and the same down here with B3 and B4, and you would just break this right here in the middle so that B3 would be feeding this top part, and B4 down here would be feeding the bottom. And then I'll show you one other little modification I would do as part of that. I would take right here where these the cathodes feed here. If you notice, both cathodes on this are tied together. They feed up to a common point that's tied with the two cathodes on these two tubes right here, and then both of those end up ultimately, as you can see here, they feed over here basically to a common ground point here between the transformers. What I would do is, in this little section right here where my hand's waving, and then this little section here, and this little section here, and here, I would insert 10 ohm resistors. And basically the 10 ohm is not enough to affect the overall function of the tube, but what it does is it gives you a reference point to then be able to measure the voltage across that 10 ohms, and you would then have V divided by the 10 ohm resistor, so V over R, the voltage you measure, divided by 10 ohms. You could figure out the current feeding each of these tubes really easily, and then you could bias based on current feeding the tubes versus voltage feeding the grids. Could be a much more effective way of getting the exact bias out of this thing that you would want. But with it the way it is, with these two tubes kind of strapped together and these two up here from a grid bias standpoint, you need to put matched pairs of tubes in this thing. V8 and V9 need to be matched, and V7 and V6 need to be matched. If you went the route with adding all this additional modification, each tube, you would not have to use matched pairs, and you could bias each tube individually. Okay, to kind of point out what I was talking about, you would come off of this point right here, and you would basically feed two more of these resistors into two additional pots that you would put in parallel here, where these black and white wires feed over here and ultimately end up feeding the cathodes here. You would kind of split that out into 4 wires, one for each one of these, and then you would come over here on these yellow wires here that are all tied together, and you would tie a 10 ohm resistor between each one of these and ground. Basically would achieve what we were trying to do over there a minute ago. Then you can measure across these resistors and adjust each pot to bias each tube individually. But hey, maybe that's for another amp another day. Thanks for watching, everybody. We're going to wrap this thing up. It's playing beautifully, sounds great, and get this thing back to the customer. Thanks for watching.